So today we're going to talk about ellipses. In order to make an ellipse or an oblong figure like this, you'd take a diagonal cross section across the cone. If it were absolutely horizontal, you'd get your circle. In order to draw one of these, pretend that you'd nailed two nails into a board, tied a piece of string around both nails that was loose, then pulled that string taut with a pencil and continued to pull it around that circle, and keeping it taut, it would create an ellipse. And the geometrical definition, as you can read, the set of all points whose sum of distances from these two inner points is a constant. These two inner points are called foci, or each individually a focus. Some important concepts regarding these shapes. One, wherever the foci lie on one of the two symmetric axes, so will these things called a vertex lie. So I'll label this as one vertex, and this is another. There's two. This is also called the major axis. And the distance from that center, which we term to be HK, is some distance A. Therefore, the major axis is 2A in length. Now, on the other axis, we have endpoints there as well. These are called co-vertices. Individually, the co-vertex. The distance from the center to that co-vertex is B. This is called the minor axis, where the co-vertices lie. And it has a length of 2B. The distance from the center to a focal point is C. Turns out that A is always bigger than B in an ellipse. And there's a relationship between the A value, the B value, and the C value, where A squared equals B squared plus C squared. Relative to the orientation of these ellipses, you'll notice that if it is laying on its side, if you will, oblong and laying on its side like so, we say that horizontal major axis exists. If it's standing up tall, where the longer part is tall, that's a vertical major axis. The way to tell the two apart, since we know that A is greater than B, then A will always be the bigger number in these fractions. So in this case, the A term is under the X, hence the horizontal orientation of the ellipse, where the A value, which would be the bigger number, is under the Y, so therefore the vertical orientation. In terms of sketching an ellipse, we know the center, HK, is equal to -2 and 7. So if I go over 2 and up 1, 2, 3, 4, 5, 6, 7, put a dot there, I know that's my center. I know the biggest term is under the Y, so this is going to have a vertical major. In this case, A is equal to 5 and B is equal to 2. So if I go up 5 and down 5, these are my vertices, and my co-vertices will be over 2 in each direction. And then kind of connect the dots in an arcing pattern, and it'll be a sketch. Obviously, it doesn't have to be perfect, of an ellipse. Now we're going to identify what the center is, the foci, and the vertices. I usually like to kind of sketch along as I do this. So I'll draw this over here. We know a few things. One, we know the center, in this case, is given to us by -2 and -5. I'll go ahead and sketch that over here. Call this -2. Call this -5. Put a dot there. And then I know the bigger number is under the X, so I have a horizontal major. We have an A value of 6 and a B value of 4 in this case. I know that the bigger number. So from here, if we move out 6 in either direction, we get a vertex And if we move up and down 4, we get a covertex. Like so. They don't ask for the co-vertices, just the vertices. So you'll notice that if I'm going out 6 from the center value, then I can say my vertices are at -2, which is the center, and then I go left and right 6. Left and right is adding and subtracting to the x, and I go down 5. So that's going to give me values of 4, -5, and -8, -5. For the focal distance, I know a squared equals b squared plus c squared. The a squared we already said was 36. B squared is 16. Left to find c squared, which is 20. So 2 root 5 is equal to c. And again, those focal distances are going to be on the major axis somewhere between the center and the vertices. So if I want the focal distances, I know they're again 2 root 5, and if I move horizontally from the center coordinate of the x, left and right 2 root 5, I will get to my focal point, and we're not going to change that to decimals. So in this case, we're going to write an equation given some information about the ellipse. Again, I'll sketch this out. I find it helps. We know that 7 up and 7 down gets me my vertice points. Therefore, dead center middle, which is 0, 0, is going to be my center. So I can write x squared plus y squared equals 1. I know my vertices are vertical, so my a term has to go under here. Therefore, that's going to be 49 since the distance to the vertex is 7, and I square that. And then I know the minor axis has a length of 6. The minor axis length is 2b. So b is equal to 3. Therefore, b squared gives me 9. This one's a little more complex. Let's go ahead and sketch that out as well. So at the point 1, 5, I have a value, and then up here at 13, let's call it, up here is 13. I have another value. These are both vertices. There's 8 between them, therefore dead center between that is 4 more from 5, which puts me at 9, and that's my center. So right now I can go ahead and write x minus 1 quantity squared plus y minus 9 quantity squared equals 1. I have a vertical major axis again. The a value in this case is 4, therefore a squared is 16. I have a focal distance, puts me at 7 and 11. That's a focus, and that's a focus. Those distances are 2 away from the center. So I know C is equal to 2, and we also know that a squared equals b squared plus c squared. A squared, as we've already stated, is 16. B squared we're looking for. C squared is equal to 4. Therefore, 12 is equal to b squared, which I can put right under that x squared term. Finding the foci in this ellipse is a little more difficult because it's in a general form rather than a standard form. We're going to need to complete the square in this case. So what I'll do is I'll group the x's and group the y's and make sure I have coefficients of 1 in front of the x squared and the y squared term. So I have 16 multiplied by x squared minus 2x, leave a space to complete the square, and 25 times y squared minus 2y, again leave a space, and bring the constant term over to the other side. So now we'll go ahead and complete the square. Half the middle term and squared is 1. Half the middle term and squared is 1 again. But you'll notice I'm not just adding 1 because there's a multiple out in front of each parentheses. So I'm really adding 16 and 25. So I have to do the same to the right side. Therefore, I have 16 times x minus 1 quantity squared plus 25 times, actually this was a plus I believe on the y. It's y plus 1 quantity squared. And that's equal to 25. Now I'll divide so I get a term on the right side of 1. I get 16 x minus 1 quantity squared over 25 plus the y plus 1 squared over 1. Now if this is in the proper form, the coefficient in front must be a 1. So this is x minus 1 quantity squared over 25/16 plus y plus 1 quantity squared over 1 is equal to 1. I can identify some terms. I know A in this case is 5/4, B in this case is 1. We also know that A squared equals B squared plus C squared, and we're going to have to find the C term in order to find the focus for the ellipse. A squared, again, is 25/16. B squared, we're just going to go with 16/16. Common denominators is equal to C squared. Therefore, 9/16 is equal to C squared, and 3/4 is equal to C. Again, since I know that in this ellipse I have a horizontal major axis, the foci have to go left and right of the center, and the foci are at 1 plus or minus 3/4 and -1. Next concept involving an ellipse and actually a hyperbola as well, which we'll get to tomorrow. It's called the eccentricity, which is a ratio of the distance to the foci and the distance to the vertex. And this eccentricity basically describes how rounded or more circular an ellipse will look. So as I get closer and closer to 0, my ellipse gets more circular. As I get further and further away from 0 and closer to 1, my ellipse will be more oblong. Let's go ahead and do a quick calculation involving an eccentricity. Here's my ellipse. I know that in this case A is equal to 3, B equals 1. We're looking for C over A to find the eccentricity, so I'm going to have to find my C value. Once again, A squared is B squared plus C squared. 9 equals 1 plus C squared. And 8's equal to C squared. 2√2 is equal to C. Therefore, my eccentricity is 2√2 over 3. And finally, we've got an application problem. It says we've got a bridge that's in a semi-elliptical shape, which is half an ellipse. It is 10 feet high off the ground at its highest point, 40 feet wide. And we want to know if the truck has a width of 10 feet and it's 9 feet high, is the whole truck going to fit under that bridge if it's going right through the middle? So if we know it's an ellipse, what I typically do is I'll put the center right in the middle and call that center 0, 0. So in doing so, I have some x squared over a squared plus y squared over b squared equals 1. And I can say that a squared is first because this bridge is greater horizontally than it is vertically. So let's plug in some values that I know. First of all, I know that the A distance is 20, the B distance is 10, and each of those will be squared. Then I know I have a distance, half that truck is 5, the X value is 5, and I'm looking for the height of that truck in this case. Now, what I need to know, because in theory I'm plugging in the A and B values for the bridge itself, I need to know at 5 meters out how tall is the bridge. Okay, and I need that bridge to be taller than 9 feet or else I'm taking off the top of the truck. All right, so I go ahead and calculate this. We'll multiply by 400. So that 400 goes with the 20 squared, and I'm left with 25. Plus, this is 100 and 400, so that's 4y squared is equal to 400. So 375 over 4 is equal to y squared. And again, we want this value to be over 9 feet if at all possible, so we don't lose any of the truck. And when I square root that, I get roughly 9.68 feet, and that's the bridge height, which means our truck is going to clear by just a little bit. All right, that's all we've got for today. We'll talk to you next time.